Next it says graph each system of linear inequalities and shade your solution. So we're going to pull out the Clemson Tiger colors here. We got some orange and purple. All right, I'm going to use orange for this first equation. So my m value is 2/3 and my b value is 3. Let's go ahead and graph that line first. So 1, 2, 3 is my y-intercept. And my slope is 2/3, so I'm going to go up 2 to the right 3. 1, 2, 3. If I go up 2 to the right 3, I'm going to go off the graph. So now I'm going to, from here, I'm going to go down 2, 1, 2, and to the left 3, 1, 2, 3. By going down and left, I'm taking care of that negative. 2 negatives make a positive. Oh, you know what? I could do one more. 1, 2, 1, 2, 3. All right. Remember, there's a solid line under that inequality sign. So I'm going to make this a solid line. Now I'm going to wait to shade this guy until I graph both of the lines, because if we shade, it might get a little messy. So here, I'm going to use purple. Go Tigers. M and B. So my B value is -3. And then I can either go up 4 to the left 3 or down 4 to the right 3. I'm going to go up 4, 2, 3, 4, and to the left 3. 1, 2, 3. Oh, nice. Those match up. 1, 2, 3, 4. 1, 2, 3. If I go down 4 to the right 3, I'm going to go off, so I'm just going to leave it like that. And there is no solid line underneath that inequality sign, so that means I'm going to have a dashed line. Okay? So now that we have those both graphed, let's go ahead and work on our shading. So I'm going to do the test point for the very first equation. I'll do it in orange just to keep everything nice and organized for you guys. So I'm going to test the point 0, 0, just because it's not on that line, all right? Like I said, use 0, 0 as much as you can, okay? So 0 is greater than or equal to 2/3 times 0 plus 3, which is 0 is greater than or equal to, that just equals 0, right? 2/3 times 0 is 0, plus 3 is just 3. Is that statement true? Nope, it's false. So I can't shade right here because that's not a solution, so I'm going to shade up above. Okay. Let's do the same thing for the purple guy. I still am going to use the test point 0, 0. Again, you guys are allowed to test any point. I just would not test one that's on a line. All right, so 0 is greater than -4/3, 0 minus 3. We can get, 0 is greater than, that's going to equal 0, minus 3. 0 is greater than 0 minus 3 is -3. Is that statement true? Yes, it is. 0 is greater than all negative numbers. So because that's true, here's my point 0, 0. So I have to shade on this side of the graph because that's a solution. Now, where the two shadings intersect is where your solution is, okay? So this area, those are your solutions, okay? Alrighty. Also, any point that lies on a solid line is a solution. Any point that's on a dashed line is not a solution. So it's got to be on the solid line to say that it's a solution. So here you can see that system of inequalities is graphed in Desmos, and notice that -3, 3 and 0, 3 are both solutions. 0, 3 is a solution because it's on the solid line within the shading. Now look what happens when I take away the solid line from the first inequality. Even though the shading was in the same region, because the orange inequality is a dashed line, 0, 3 is no longer a solution. Now let's look at what happens if we flip the inequality sign for the purple inequality. As you can see here, the intersection of the shaded region moves. Therefore, -3, 3 and 0, 3 are no longer solutions. An example that would be a solution would be -6, 2. So as you can see from this lesson, it is very important to use test points to figure out where your solutions are for your system of inequalities.